Productivity zones are areas in a field with different yield history. The area with the highest yield in the field for several seasons is a high productivity zone. The area with the lowest yield for the several seasons is a low productivity zone. Productivity zones are the best method to do VRA because they have high quality, they are easy to interpret, and they have low cost. Productivity zones creation is multi-temporal analysis for 5+ seasons. And in my experience, yield data is the most exact way to delineate productivity zones. But there are two buts. The first one, to build productivity zones, we need yield data for 5+ seasons. And farmers typically don't have yield data for 5+ seasons. The second part is that if farmers have yield data for 5+ seasons, this data often uncalibrated, and we cannot use uncalibrated data from harvester to build productivity zones. In the slide, you can see example. Yield data for one of our fields, harvester was uncalibrated, and we cannot use this yield data to build productivity zones. However, vegetation index has a strong correlation with yield data in the certain phenological stage for some crops, not for all of them. We know it because for 7 years we have been gathering hundreds of thousands yield data from harvesters, and our R&D department compares this data with vegetation. Here's one of the most important points, that the main goal of productivity zones is to predict yield distribution for the next season based on data from previous seasons. You can see in the left image productivity zones based on 3 years of yield data. In the right image, you can see productivity zones based on 3 years of satellite data. As you can see, between these maps have the same pattern of distribution of productivity. It means that we can use productivity zones based on satellite data to create a task map and use this task map in our equipment. Most of our competitors use the average vegetation index to build productivity zones. As I mentioned before, to build our productivity zones, we use our own algorithm, which include 5 steps. And here we separate field by 2 groups, easy field and difficult field. Easy field is field with stable vegetation, optimum crop rotation, and field boundaries have not been changed. Difficult field is field with unstable vegetation, not optimal crop rotation, and the field boundaries have been changed. In the slide, you can see an example for easy field and for difficult field. Let's start with easy one. For this field has good crop rotation to build productivity zones. Corn is monocrop for this field. And also, field boundary had not been changed for 7 seasons. As you can see, our zones and productivity zones from one of our competitors almost the same. And both of these maps have the same trend with yield data. Now let's go to difficult field. For this field has crop rotation with 4 crops: canola, wheat, barley, and corn. Also, for 2 seasons, field boundary has been changed. And as you can see in the slide, our productivity zones and productivity zones from one of our competitors are totally different. And productivity zones from OneSoil predict yield distribution much better. I would like to highlight it again. Productivity zones aim to predict yield distribution in typical weather conditions and for crops that have a correlation between vegetation index and yield.